Hey, good day, class. Welcome back sa ato ang course on Computational Physics 2, Introduction to Numerical Analysis and Methods in Physics. So, I hope all is well sa inyo ha, regarding sa ato ang midterm coverage. Sumubo naman to, ato ang midterm coverage and uh, quite easy ra po to siya nga mga topics. I hope ma-manage na ninyo or makaya ang mga concepts ato. But if you have questions, uh, don't hesitate to contact me or email me for that matter. If you have questions, then I will surely respond or reply to your queries. Basin na mo ikalibugan nga concept or naisayop sa ako ang code or maybe sa inyong end, dili siya mo run. So just tell me lang. Okay? So for this course, we are now halfway sa to ang topic and we are now actually down to uh, three remaining topics sa ato ang course. So sa final coverage, turo na lang ka topics ang ato ang i-discuss. Hubo na lang siya. And also, sayon ra pod actually. So don't worry, sayon ra ang mga topics sa final term. So sa finals, we'll be discussing on numerical integration. Okay, this topic. Okay, I know nakahuman na mo aning integration nga topic or naka-take up na mo partly sa high school and sa inyong as one of your subjects pod karon sa BS Physics nga program. I think karon nga sem nagkamulo pa mo og discuss but some of the topics especially sa fundamentals and basics integration were already discussed by your professor. Okay? So somehow na mo yung knowledge ani. And then we also discuss numerical differentiation. Okay? So numerical or approximation sa integration, approximation sa taking the derivative. So what are the techniques and methods or algorithms employed in order to achieve or to solve these two uh, tool needed in physics? You have integration and differentiation. And then the last topic would be all about ordinary differential equation. So we don't have time na para mag-discuss pa kita sa napatay supposedly mag-discuss pero sige na lang mo explore na lang mo ana on your own. Anyway, sayo na naman po. So di na tayo mag-discuss ng partial differential equation but ano lang, ordinary differential equation of first order. Okay? So ordinary differential equation of first order and I think wala pa mo kaagian kani nga part but this is manageable naman na siya. So along the way, I will discuss a little bit about our ordinary differential equation and how do we solve it using analytical means or kana mag pen and paper gid ba. And for our case, we'll be using numerical means kay ato mang i-approximate, okay? So we'll do approximation and we'll find out later nga ang result sa kani we have numerical means of these three topics. The result ana is in good agreement siya sa actual or sa exact solution. So we'll see later on. Okay, so I'll just have to close lang Okay. So this will be our topic. Remaining topics kaning tulo, numerical integration, differentiation, and ordinary differential equation. So for this topic, we'll dive into numerical integration. This is our topic for today. So under numerical integration, we'll be discussing the following sections. So as you can see here sa page, we have primitive integration. You will also be learning what quadrature is, composite rule in integration. We have Euler-Maclaurin formula. We have the Gaussian quadrature And lastly, the Monte Carlo integration. Napadi additional ani mo ato nang i-include diri ang MATLAB's own integration routine. Okay? Okay, so integration. So what basically integration is? Ba, naka-discuss naman mo integration. So integration is it's very useful siya nga tool, and mo- most fields sa science ginagamit yun ani because part na siya sa calculus. We have differentiation, integration. So in simple terms, at its core, fundamentally, integration is just finding the area, di ba? So integration is finding the area under the curve. Okay. Anak naman na siya. So if you have your curve here, your function f of x. Okay. So integration is just finding the area, okay, under the curve sa kaning function, let's say function f. Okay. So that's the basic idea of integration. And integration is considered to be the most common task and frequently encountered by physicists. Sometimes, most of the time, because we physicists try to describe phenomena through mathematical modeling. So we need to understand a certain phenomena and we model it using equations. Okay. Example, kay Newton's uh, from Newton's law, so this is the simplest Newton's law, to a much more complex phenomena wherein gamit o ba complicated ng mga equations and integration such as string theory, you have your quantum gravity, and also the standard models of physics. Okay, so there are a lot of ways to solve or to evaluate the integral, or a lot of ways that you can do integration. There are a lot of techniques, right? Analytically, so daghang techniques nga pwede buhaton nga ma-solve nimo ang imuhang particular integral. Okay, and maybe na-discuss ninyo na gamay sa inyong calculus karon on how to do integration. There are several techniques, and one such technique is this integration by parts, by partial fraction, and so on. And for our case, we will have our numerical integration as one such tool or additional tool nga ato ang ma-add sa ato ang reservoir of integration tools. Okay? So I will not beat around the bush, and this time we will directly discuss, or immediately we will discuss immediately right now what numerical integration is. So you will get to know the numerical integration and why is it useful and how do we apply it in solving problems in almost all field of science. So first we'll discuss uh, the primitive integration because this is this first step in understanding numerical integration. Okay, by ano siya ba, by baka tinamban siya nga way of how of integrating it. So we need this type of integration kani nga concept, the primitive integration. Okay, simplified mo na siya wherein the algorithm can be implemented on a computer, wherein computer can understand step by step, and then you can solve the integral, any integral. Okay. So evaluating integrals numerically will prove useful if one is integrating a certain function that has no existing simple alternative. So diri mo sulod actually ang numerical integration if by any chance lisod kaayo isolve ba ang imong integration. But if that integral is sayo na kay siya i-integrate, let's say if you have example nga sayo na integrate nga integral, you have x squared dx, we can actually integrate it easily, extremely easier na siya using using analytical means. Di ba? Anak naman na siya. We have x cubed over 3 kasi evaluated from A to B. Evaluated from A to B. So there's no reason for us to use numerical integration sa kaninga case. Kaya exactly makuha mo na mo ang answer. Numerical integration will come into picture if a certain integral is difficult or almost impossible to solve by hand. Okay? So dili na masulod ang numerical integration. So to begin with, we will start with some simple brute force type of numerical means in evaluating different integrals. So generally, we have this form sa tuwang integral. Okay, so generally, we have this form sa tuwang integral from a to b. Say f of x dx. So it is a well-behaved function over the interval a to b. So one can look for the integral in this equation by evaluating it at specific points or location, and then use that function evaluation to make an approximation of an integral. So what we are actually looking to determine the result of this integral is by using a formula, a primitive form. Ano siya? So integral is ano naman na siya? Summation, di ba? So we have where I runs from 0 to n. Okay. So we need to find unsa ni siya. Okay. This is an approximation of our integral. So we have any function f of x that can be approximated by having this. Okay. So sum siya sa weights. This is weights. And this is your, let's say, abscissas. So kung imo nang i-expand, you have w1 f, this is start from 0, f0 plus w1 f1 and so on. Okay, depende kung ila kabog imong n, imong points. Okay. So where fi is x of I, ano siya? W is the weight, and this one is the number of points evaluated. So in general, you have n plus 1 point, right? So to keep things simple for now, we will assume that each evaluation point is spaced out evenly. Okay? So let's say, ang imong evaluation point is spaced out evenly. Okay? Spaced out evenly by a distance h. Okay? So let's start deriving a closed formula, one that uses a function evaluation at the endpoints of the integration. Okay? So very simple formula that we can use in approximating the integral is having this equation. Let's say we'll call this I, okay? The integral. So we have I, so we'll call this I. So approximately the integral is W naught F naught plus W1 F1. So kana lang. Okay? Where X naught, ang imuhang starting is katong A, tapos ang imuhang X1 is, let's say, B. So next, we want this approximation to be applicable to other forms of integrals. Okay? Let's say we want this integral to be applicable sa kaninga form. We have f of x equals 1 and also f of x equals x. Actually, polynomial na siya. This is just x to the 0. This is x to the 1. So this is this type of doing, this method of doing integration is you make an approximation sa imong function by using a polynomial. Okay? Let's say kanilang mga simple nga polynomial. We have 1 and then you have x to the 1. So notice nga mao ni siya ang imong first two terms, di ba? Mao ni siya ang first two terms. Okay. These are your first two terms of your Taylor series, right? You have 1 plus x and so on. Okay? So, we'll derive a formula. Okay? Kanisha, we'll derive a formula. So, we'll have to determine unsa ka ng W1, unsa ka ng W0. Okay? By by considering nga exact iyang solution sa kaning duha ka function. We have f of x equals 1 and f of x equals x. So start with this one. So you have x naught to x1 ang ato ang evaluation point. And then the first function is 1 dx. If you integrate that one, automatic naman na siya x, di ba? I have x naught evaluated from x naught to x1. So this is x1 minus x naught. And this is equated to, tara, kahit naman ang result. So we have w0 times f1, oh, f0 I mean, plus this is 0, w1, f1. Next, another function na to is f of x equals x. So we have x dx. So unsa ka ang value sa atong unknown actually ani is unsa ka ni siya. Right? Unsa nang w0 and wf1 in such a way nga mo satisfy sa ani. Right? This first two simple nga mga polynomial function. So if you integrate this one, you get x squared over 2 evaluated from x naught to x1. So this would be x1 squared over 2 minus, ato na lang i-simplify. Iusa, we have x1 squared minus x naught squared over 2. Okay? And this is equal to w naught f naught plus w1 f1. Okay. So ato ang goal ani is if we have to determine the w naught, we have to determine the w naught and the w1. So the two unknowns, so we need two equations. So okay ra natin duha ka equation, this one and this. So atong i-rewrite. So how do we solve for unknowns w naught? Kumuha man na ang weights sa imong integral, ang result niya para maka-approximate ta. We have x1 squared minus x2 squared over 2 equals sorry. Okay, tama. Para. So sa kanina case, ang f naught na to, which is, ang f naught na to is ada man na. F naught is f of x naught. Right? Since 1 man is siya, since f of x is equal to 1, so always na siya 1. So 1 na ni siya. So 1 pod na. So that would be w naught plus w1 na lang. For this case, f naught would be x naught squared. X naught lang. Okay, ayun sa kanina case, this one, your f of x is x, right? Mama na siya. So if it is x naught, so we have f of x naught is x naught. So we have x naught. Ang f of 1 mo is x1. Okay? So we can solve for the weights. So we have w naught plus w1, and then we have w naught x naught plus w1 f1. So this is easy to solve. How do we get w naught? So ito siya i-eliminate lang. So I can actually multiply this with x naught so that I can eliminate w naught. So ako siya i-multiply, right? On all parts sa mong equation. So mahitabo ko na lang i-rewrite. Right? So this becomes x naught minus x naught squared multiply equals w naught x naught plus w1 x1. So this is x1. And then kaning ubos, we have x1 squared over 2. So, pwede na x, this is ups, this is not, okay? So, we have x naught squared over 2 equals w naught, x naught plus w, dagang sayop. This is x naught, x1, okay? So, na. Then, ato siya i-minus para ma-eliminate na to. So, this becomes eliminated. Wala na na. So, mabili na lang is gani. So, you have x naught minus x naught squared minus x1 squared over 2 plus, right? Gani siya. Mapa-plus man. Oh, yeah. Mapa-plus. We have x naught squared over 2 equals w1. So, w1 is common nila is, di ba, x naught plus x1. Okay. So, how do we do about it? So, pwede naman na siya ma-simplify, right? So, we have, this is x1, x1, so this is x1, so this is x1. Okay. So, pwede na to ma-simplify ang, diba? So, so, ito na i-simplify. You have x1, x naught. So, makombine na to ang mga x naught. So, that's actually minus x naught squared over 2. Then, we are left with x1 squared over 2. w1 x naught plus x1. Okay. So, have this. Okay. Kung ako nalimtan din so this is minus, right? So kani siya pag i-minus ni mo ni siya og kani. So actually minus na siya. This is minus. So this is minus. Okay? I hope clear na siya. So we can rewrite this as let's say x1 squared over 2 plus x1 x naught minus x naught squared over 2. Okay. And then we can do a factoring sa kaning I hope mao ba? So you have so sakto rin siya. We have plus, this is ako siyang i-plus, right? So dapat ma-minus ni siya. Okay, so let's say akong gipang transpose dito. So this becomes negative, right? I hope naka-follow ra. So akong i-opposite ang sign kasi multiply na ko siya negative sa tanan. So this becomes positive. So this becomes positive po. Okay? And then I have that. Then we can simplify this. Kani siya nga equation. actually is just, if you can notice, x1 minus x naught squared times 1/2, right? So, kanin siya is equal na siya ani. This one is equal ana. Ay, manotice mo na ninyo. Okay, if you expand this one, x1 squared minus 2 x1 x naught plus x naught squared, then you multiply it by 1/2, you get this. And then, you have w1, o ibutang ang negative sa sulod, x1 minus x naught. So, mag-cancel na siya. Kana. So, w1 is just x1 minus x naught. X1 minus x naught over 2. And if you substitute it here, gani din here, sa kaning equation. Yeah, sa kaning equation to get the w naught, we'll also find that w naught is equal to the same sa w1. Okay, so you got this weight. And then, we have now our results ato ang primitive integration. So we have I, which is, we have w naught f1 plus f naught w1 f1. Where w naught is just x1 minus x naught, diba? So x1 minus x naught over 2 times f naught plus w1 is also the same, w is equal to x1 minus x naught over 2 times f1. And then to simplify things, kaning x1 minus x naught, we'll call that by h. Ato ang, let's say, iyahang, baga, later on, ma-term ni siya as iyahang interval. Okay? So we can have h over 2 f naught plus f1. Okay? So this would be the result sa to integration. So actually mo ni siya from x naught to x1. So approximate na siya. So we have f of x dx. Okay. So by using this, dali na din siya ato nato siya ma-program because this is how you do numerical means or numerical you integrate certain function using numerical means. Okay? So this is what we call a trapezoid rule. A trapezoid rule because it's really a trapezoid ang formula. So for example, if I have a function, so gi-approximate again siya using a trapezoid. So you have your x naught here, and this is your x1, right? So gigamit na niya ang trapezoid. So for this case, masyad na, right? If i-connect na siya. So it's like you have a trapezoid or para mas klaro ano. So you have your function in ana. So this is your ana. And then siya i-kuan diha. It's like a trapezoid, right? And the formula sa trapezoid is, let's say, formula sa kaning area, sa kaning trapezoid, right? Kasi this is base 1 and this is base 2. And then, kanin siya is your h, right? It's like your height. So the formula sa trapezoid, iyahang area sa trapezoid. It's actually 1/2 height times ang base 1 plus base 2. Now this is actually the same, yeah, equation. So this is your height and this is your base. Your base is kanisya, your function at f of x naught and the function at x1, f of x1. Okay, so that's why it's called a trapezoid rule in evaluating the integral of this or the result of the integration sa kaning function. So that's the trapezoid rule. Okay. Okay, so how about if we extend our integration nga instead na trapezoid, how about kung ano siya? So instead na trapezoid, so you have your function. It's like pa-curve po ng iyahang pag ano ba, pag approximate. Okay? So you have instead na straight line or trapezoid, mo siya i-follow with the curve. We can do that using not the trapezoid but the Simpsons rule. Okay, Simpsons. So sa Simpsons rule, quadratic na ang ihang form. So instead of a 1 point, you have a 3 point na. So from x naught up to x2 na ta. Okay? And we'll see why nganong x2 na siya because 3 point man siya. So true siya for f of x. For x ka function. And also for x squared, so quadratic na siya. Kaganina is tama naman ta aning duha, di ba? For trapezoid rule. And this one is x2 minus x naught equals, so 3 point naman, so you have w naught plus w1 plus w2. Okay? And then sa kanipod, you have x2 squared minus x naught squared over 2. So this would be w naught x naught plus w1 x1 plus w2 x2. So tulo na siya kaanon. We have w naught, w1, and w2. So this is the Simpsons rule. Quadratic na ang gamit. You have quadratic. So this becomes x2 cubed minus x naught cubed over 3. So this would be w naught x naught squared, right? Okay. X squared man plus w1 x1 squared plus w2 x2 squared. So to give us the result sa Simpsons rule, you need to determine w0, w1, and w2 using three equations. Tulo ka equation because tulo man ta ka-unknown. So that's why tulo ka equation. You can solve that using matrix formulation. But for the purpose ato ang study kanon, I'll give you directly the result sa kaning equation, tulo ka equation to get the three unknowns. And it's found out nga for the Simpsons rule, mo ni ang iyang result. So it's actually given by h over 3. Okay. F1 plus 4. F1. So muna ang mga weights niya. Plus F2. Okay. 1, ang coefficient niya is 1, 4, and then 1. Okay, this is the Simpson rule. So continuing this to 4 point. Okay, so 4 point na. Kani is 3 point man eh, right? This is 3 point. You have x naught, x1, x2. For 4 point, you have x naught padulong x3. So, yan ako ikuan ang details sa pag-solve. Basta kay mo ni siya ang iyang result. For the 4 point, you have 3h over 8 times f naught plus 3f1 plus 3f2 plus f3. And this is what we call the Simpsons 3/8 rule. 3/8 rule. Okay, so 4 point na siya. So continuing further with 5 points, pwede gihapon. So mas ano siya, mas taas iyang level of accuracy. It's in approximating the integral. So for 5 point na evaluation sa mong points sa mong integration, you have 2h over 45. So this is 7 f naught plus 32 f1 plus 12 f2 plus 32 f3 plus 7 f4. So this is like ang Simpson nimo is ang katong trapezoid is linear man to, right? It's like pag-approximate mo sa imong integral ba kana siya line, a straight line. For the Simpson rule, it's like a quadratic, a curve. For the Simpson's 3/8 rule, so quadratic na cubic na siya ang iyahang pag-approximate sa curve. Kanipod is for the cubic, and you have a quadratic, cubic, and then you have a quartic. So this is Boole's rule. Boolean. This is Boole's. I don't know sa pag-pronounce anak Boole's or Boole's. Boole's rule. Okay. So this integration formula, ang gi-require niya is ang f of x is a polynomial. Gi-approximate siya as a polynomial. Right? So kani siya is ang Simpson's rule, order 2 man siya, right? Quadratic, and this is cubic, and this is quartic. So with all this complication, although di na kaya siya complicated, kasi ang complicated lang ani nga part is, ang kuti nga part is ang pag-solve, right? But once makuha na ninyo siya, then simple naman ang iyang form. So you have the Simpson's rule, you have the Simpson's 3/8 rule, and the Boole's rule. So given this different types of integration tool na to, numerical, you have also the trapezoid, this one, trapezoid. This can be done on a computer. Okay, iteration na naman ni siya. So F0, F1, F2, and so on. Right? Makuha mo, ma-solve ba siya using a computer. You will be writing later on your own program or code. Sa na siya pag-solve. So we can look for another alternative pa-solve ni siya in which mas accurate po. We will look at a composite formulas, an alternative. Formulas, an alternative. So we can look for a very good alternative in evaluating integrals instead of doing the higher order approximation, katong higher order ta from trapezoid, higher order ta to Simpson, which is squared, Simpson's 3/8 rule, cubic, Boole's rule, we have quartic. So instead of moadto ta sa higher nga order approximation, we can just use the trapezoid. Okay, masayin man ang trapezoid. And then what we will do is we will divide the integration area into many parts or many segments. Okay, so for example, we have this curve, and then we are asked to find what is the integral, or what is the integral of this function. So starting from x0 to x1. So instead na magamit atong higher order pa curve siya, why not we can just use the trapezoid, but we have to divide the interval into many parts, right? So divide na to na siya na, right? So we can divide this in many parts. So in such a way, each segment here, each segment is actually a trapezoid, right? Then po, another trapezoid, and so on. So i-add ra nimo siya. So we can have this formula from x naught instead of from x1. Okay, sorry. xn. So this is x naught, and then this is x1, this is x2, this is x3, and so on. Okay. So x naught up to xn, f of x dx. Can approximate that to, so each segment kani is a trapezoid, and we know the formula sa trapezoid. We have h over 2. Let's say ang interval ani is h. So x1 minus x naught is h. Also x2 minus x1 is h, and so on. So h over 2 times katong duha ka base, yeah, f naught plus f1, plus move na punta sa next nga trapezoid or segment. We have h over 2 gihapon. Then from f1 to f2. Tapos na po f2, f3, and so on. So plus h over 2 sa end part na kay f of n minus 1 plus f to the n, right? So that would be your formula. So this is a lot easier to handle because atong gigamit lang is trapezoid. Wala ta nag-complicate ato ta sa higher order. Although pwede gihapon na later. Atong i-apply ni siya ang Simpson's rule with this type of uh, um, methodology or thinking. We have the composite formula. Okay, so we can simplify this. Now, so this is actually h times, so we have f naught over 2 plus, so if imo siya i-expand bitaw, this is h naught over 2, right? F naught over 2 plus, so ang h naught og f1, we have h1 hf1 over 2 plus, can you see the same, right? So that would be f1 na lang. Okay, puros man 1 half. So 1 half plus 1 half equals 1. That becomes f1. This is true po sa f2, right? I hope makita ninyo ang pattern. So nakuha 1 half dira. Can you put 1 half, then 1 half, so becomes 1. We have f2 plus f3. Ang mabili na lang is fn over 2, wala siya pares, right? Pareha sa f naught, kasugod wala siya partner. So this would be your integral. Okay. So this is composite rule using trapezoid. Kay mas ano man siya, mas sayon, and although exact po siya kay i-divide, the more nimo i-divide ang segment into many parts, mas magka-close sa true value ang imuhang result. So a similar procedure can also be done using composite Simpson's rule. So this is composite trapezoid rule. You can also use the composite Simpson's rule. And that is given by this. So h over 3 f naught plus 4f1 plus 2f2 plus so on 2 fn minus 2 plus 4 fn minus 1 plus f sub n. So this would be the composite Simpson's rule or formula. So this equation, the composite Simpson's rule, is more accurate than the composite trapezoid since the composite Simpson's rule makes use of a quadratic approximation as opposed to a linear approximation sa trapezoid rule. So we can even take this further to better approximation of our integral employing cubic and quartic, right? Ang cubic na to is katong Simpson's 3/8 rule, and quartic is the Boole's rule. So pwede na to na siya instead na from x na to x, saan siya? X na to x4, you can take it to, i-divide mo siya ba? From x na to xn siya. Okay? Now we will have example. So example. Evaluate the integral. So saan pag-evaluate sa integral kaning sin x dx from 0 to pi using the approximations to the integrand, okay, using linear, cubic, quartic approximations. Okay, with n starting from 4.816 up to 1024. Then we compare the accuracy of each method. Okay, so we'll be using, let's say this one, the composite trapezoid, in evaluating the integral sin x from 0 to pi, and also we'll be using the composite Simpson's rule. So we know before ta mag-integrate kaya ta unsay result ani unsay atong expected nga result because this is easy to solve. So analytically, we can integrate sin x very easily. Di ba? Negative cosine, negative cosine x evaluated from 0 to pi. So this is negative cosine pi minus cosine 0. So that would be 1. 1. Tama ba? Yeah, tama. Narang ko na mali sa sign. Sorry. This is negative, right? Cosine pi minus cosine 0. So dapat ana. So you have negative, so this is negative 1. Cosine pi is negative 1 minus 1. So this becomes 2. So dapat 2 atong result. Okay? So ato anang i-open ato ang program sa MATLAB, then we'll try to solve it using these methods. You have the composite trapezoid rule and the composite Simpson's rule. And that would be sa next part sa atong video. Okay, it's almost 1 hour na. Okay, see you on the next vid para sa ato ang implementation sa MATLAB using these methods.